We are going to talk about proportional relationships. So we did this example in school yesterday. Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? And was the table where you looked at 25 minutes, 2 miles, 50 minutes, 4 miles, 75 minutes, 6 miles. And now you have to see the relationship. So when you answer these questions, how many miles would Paul be able to walk in 50 minutes? You should be able to explain the pattern. What is happening here? For example, 25 minutes, what is happening? When it becomes 50, what happens to 2 miles? How many miles does it pick up? So look at this relationship and explain these. Explain and write the answers. So here it was. Now you could see that Paul could walk 4 miles in 50 minutes, which is twice the time that we are given. And again, 25 also becomes twice the distance. Similarly, 3 times the distance here, which is 75, 3 times the time here, which is 75 minutes. The distance also becomes 3 times, which is 6 miles. So this is the relationship. So if it is 4 times the distance, 4 times is the time here, the distance also becomes 4 times, and so on. This should be actually 100. The 10, sorry, this is 100 minutes, 8 miles, and 125 minutes, 10 miles. So how are you going to determine the number of miles Paul could walk in 137.5 minutes? And give the explanation. So I'm sure this is the way that you've worked out with unit rate. 25 upon 2 is equal to 137.5 upon y, and y is equal to 11. Therefore, Paul could walk 11 miles in 137.5 minutes. Now, since this relationship between distance Paul walks and the time it takes him to walk is proportional, which is your distance 25 upon 2, 20, it's a unitary method, 25 minutes, and you cover 2 miles. In 1 minute, you will cover 25 upon 2. Now, this is the proportional rate. So this is equal to 137.5. The rate remains the same. If you see 50 upon 4 is, if you bring it to shorter form, is 25 upon 2. 75 upon 6 is also 25 upon 2. So this proportion 100 upon 8 is also 25 upon 2. So the ratio of the time and the distance, which is also the unitary method, is the same as 25 upon 2. Therefore, if you need to find the if you need to find the distance covered in 137.5 minutes, this ratio will be equal to the ratio of the same 137.5 minutes upon y. Y is something we need to find how many miles, and this is will remain the same. So the proportions will remain the same. Similarly, now if you need to find out, therefore, if the distance is y and time is x, then how many miles y can Paul walk in x minutes? If the distance is x and the the distance is y and time is x, what will be your equation? So can you write down the equation in this form? If your time is x and your distance is y, what will this equation be? So this is the ratio 25 upon 2, and you can see that this is the relationship between each. So you can write 25 upon 2 will be x upon y. Now, does it remind you of something we've done? How will you solve this? So you know that Paul can walk 2 miles in 25 minutes. So we can write ratio 25 upon 2 as we did with this proportion. We can write another ratio for number of miles. Y is Paul walks in x minutes. It is x upon y, and therefore we could write the proportion. We can write it this way. The ratios for both will remain the same. So this is the proportion. 25 upon 2 is equal to x upon y. Now, how are you going to solve this? Does this remind you of something we've done recently? Explain. How are you explaining? Which the question means, how are we going to solve it? What will be the equation when we cross multiply these? What will your equation be in terms of y? What is y equal to? Guess. This is a linear equation in disguise. All we need to do is multiply 25y is x, 2x, and then y is 2 upon 25x, which is y is equal to 0.08x. We know x is the independent variable. Y is the dependent. It is dependent on x. And what is the relationship between y and x? It is 0.08x, which means Paul can walk 0.08x miles in x minutes. This is what it means. Which means if it is 2 minutes, so it will walk 0.08. Sorry, if it is 25 minutes, it will walk x is 25, 0.08 into 25, which will be 2 miles. If it is 50 minutes, 0.08 into 50, which will give you 4 miles. So your distance is dependent on the time. The more the time is, the more distance they'll be covered. And this is the relationship. So 0.08, that is the proportional relationship. It is y is 0.08x times 0.08 times x. So which is given here. Now let's go back to this table. I have explained everything. Look at the pattern here. Use this pattern to answer this question. Y is 0.0 or its equivalent. What do you notice? So I have explained in my previous, and write down this, whatever you notice here. So these are the things we notice, that fraction 2 upon 25, which is distance upon time, came from the first row. This is the distance traveled divided by the time it took to travel the distance. That's 2 divided by 25. It is also, for example, it is also in between. For example, 4 miles upon 50 will also give you 2 upon 25. And secondly, it's the same ratio. It's also, for example, the difference between 4 miles and 2 is 2. So if this is double, this is also double. The difference is 25. Again, between 4 and 6, it's 2. 50 and 75, it's 25. The pattern repeats throughout this table. So we've discussed this. I want to that the unit rate between each value, time in minutes, is the same, which is if 50 minutes it travels 4 miles, then in 1 minute it will be 4 upon 50, which is 2 upon 25. If 75 minutes they walk 6 miles, then in 1 minute it will be 6 upon 75, which is equal to 2 upon 25. So unit rate remains the same with all the timings. Now you look at this problem, and we want to know how many miles y can be traveled in any number of hours x. Using the previous work, what should we do? So you have to find out the proportion rate, the equation of y. You should be able to find out what is the distance y can be traveled. How many miles y can be traveled in any number of hours x. The same equation that we found previously. Thank you.